Hello, Amrit. Amrit.
Hello.
Hello, Amrit. Am I audible?
Yes. Just give me a moment. Hello.
Hello.
I'm not getting the audio in my mic. Just give me a moment.
Okay. Take your time.
My voice is audible, right, Madam Prakash? My voice is audible, ma'am?
Yeah, yeah.
Oh,
Actually, my audio is coming up in the system volume.
It's fine now. We can hear you.
Hello, Manavita ma'am. Am I
Ah,
audible?
yes, you're audible.
Okay. Now I'm
We
able
would,
to.
yeah, we'll be waiting for 3 minutes and after that we'll be starting. How are you, Amrit?
Few of the participants are joining. Let us wait for 5 more minutes.
Yeah, okay.
Yeah, now it looks better.
How are you, Amrit?
I'm good. How about you, Monitadi, Monaliti?
We are also
Hi.
doing well.
Nice.
Like a busy life with work and all, I guess.
Huh?
Busy life with work and all, I guess. Am I audible?
Yes,
Hello.
yes, you're audible.
Yeah. Seven participants till now.
They are still joining. We have to wait for 2 more minutes.
Yeah.
Sure, no problem.
Mhm. Amrit, you can just check once, like if there is any PPT and all, like you want to share it, is it getting shared or not? Just check that once.
Okay, sure. I'll share my screen. I think I have the disabled access. I don't have the access to share.
Okay, that means should be.
Yeah.
Okay, just wait. Can you share now?
Okay. Is it visible now?
Yeah, yeah.
Yeah, it is visible.
Okay. So, shall I keep it sharing or just stop it?
We can start after like introduction.
Okay. So, can I start now?
The time, by the way, how many participants? Okay, 8.
Okay, Monali,
just-
you can start only.
Yeah, we can start.
Okay. So,
Amrit, good
yeah,
afternoon to all. Actually, I just want to give your introduction to all the participants before starting this.
sure.
So, yeah. So, good afternoon to all, whoever my students and some of them are still joining. So, on behalf of the School of Computer Science and Engineering, VITAT University, myself, Dr. Monali Bodloy, welcome you all to this industrial guest lecture session. on digital twin and application deployment. So the main objective of this guest session is to disseminate and promulgate the basic ideas and research directions about the topic, that is digital twin, among young researchers. We have our students here who are still, I can say they are the young researchers here, and they have a lot of scope to work in this area. And today we are very, very pleased to welcome our very dear Mr. Amrit Kumar Verma. So Mr. Amrit actually completed his BTech in Computer Science and Engineering from WBUT and MTech from National Institute of Technology, Silchar. So he's currently working as a research scientist in Siemens Technology, Karnataka, India. So I'd like to highlight some of his research experience. He has experience as a like in simulation-based testing of autonomous vehicles using Vector Simulator, then falsification-based testing of autonomous vehicles using reinforcement learning and Kala Simulator. He's also involved in building proof of concept, that is POC, for end-to-end electric vehicle charging solution. He was also involved in building minimal viable product for end-to-end electric vehicle charging solution. He also worked on Confi, that is one-stop solution for corporate offices, having responsibilities of writing back-end code, test codes, back-end and UI. And he has also conducted some hands-on research experience and DevOps to build environment as a service. So he has also research experience in feature improvements of Siemens software, example APS, SI, MIT. So he's currently working on digital tools, we call it DT, topics using NLP, that is natural language processing techniques. And today he'll be sharing with his expert opinion on that. So with that, I just request you all to pay full attention to Mr. Amrit Kumar Verma and help in welcoming him. I request Mr. Amrit to kindly take over from here. Thank you.
Thank you, Dr. Monali. Thanks for the warm welcome, and thanks to Dr. Monamita also and all the participants. I hope that I can make some impact on people life towards the technology, cutting edge technologies, as well as the research going on and the upcoming future. So without a further delay, let's get started directly into the topics. Shall I?
Yes, you can just
Yes.
share your screen.
Okay, I'll share my screen. Is my screen visible?
Yes, it's visible.
Okay.
Can you make your...
Is it visible now?
Yeah, right.
Okay. So today's topic is digital twin and application deployment. So basically, these are two different topics. So as I have nearly 1 hour of time, so I thought why not to introduce the cutting edge upcoming technologies that is going to be the future of any industry, as well as any deploy application of what is going on to the startups as well in the current market. If you see, so everything is going to be application based as well as web app based. So initially we used to have the client based software, basically like we use Microsoft Office that is going to install in our system. But right now all the applications are going to be web app. So if you see, right now if you go to office.com, there you can access all the office products like Word, Microsoft, PowerPoint, Excel, anything you can access. Just log in with your Microsoft account. So the standalone client softwares that is going to be that is going to be obsolete in upcoming future. Everything is going to be cloud based as well as you see web app based. Okay. So now these two topics, that is digital twin and application deployment, so just pay attention because these are two different topics of two different domain. So I hope that I'll make it clear what these topics are. So 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 our roadmap is divided into two different parts. So the left part to the red dotted line is basically for digital twin, and the right part is basically for application deployment. So in the roadmap, if you see, we'll start with the introduction to digital twin. Then we deep dive into the digital twin technology as well as its use cases, and few of the things I'll explain where the digital twin is going to be implemented, as well as right in current market is going it is being used. And then in the second part, we'll go with the application deployment, how it is started and what are the current scenario of application deployment things are going on, and what are the benefits we are getting as compared to the monolith architecture and the microservice architectures as well. And then we'll have a separate Q&A for both of the parts for digital twin as well as application deployment. So now, so let's start with digital twin. Okay, so what is digital twin? The first question comes in everyone's mind that okay, this is the technology, but what it is? So as the word suggests, so if you can see this, it is made of two words, digital and as well as twin. So digital is like like whatever we use in a computer have it don't have any physical existence, what is called digital, and twin is like the replica of it. So basically the digital twin is the digital replica of anything. It can be of a machine, it can be of a human, it can be of a furniture, it can be of anything you can imagine. It can be a digital replica of a physical world entities. Okay, so if you in the example in the picture, if you see, so it is I mean, we all have all might have traveled on the aircraft, or we have seen. So this is a engine of the aircraft. So if you see the on the left part of the engine, that is a basically physical existence of an engine, cryogenic engine basically, or a part of cryogenic engine. It's not exactly cryogenic, but a part of it. Now on the right side is basically a digital replica of it. Okay, so if you see each and every part, if you see on the left side the physical asset, physical existence of the engine, and the right side part is the digital existence of that particular physical engine. Okay, so this is what the difference between physical and digital. So it's a copy of a physical, in a nutshell, it's a copy of digital copy of a physical existing asset or any entity, whatever you can imagine. Okay, so you might have heard about in recent time the metaverse has going to be very in very news topic, that okay, metaverse, when Mark Zuckerberg has initiated the metaverse topic, so everything is going to be virtual as his vision. Okay, at least in current upcoming 10-20 years, we'll be able to visualize a metaverse. People already started buying NFTs and buying, even the couple of metaverse companies are open that you can buy a land in your metaverse, okay, using NFTs and all, or digital currencies like Bitcoin and all things. Okay, cryptocurrencies. So everything you imagine in the future will be based on the digital twin. We'll have the technologies like AR, VR, augmented reality, virtual reality, extended reality, mixed reality. So everything is based on this digital twin technology. Okay, so now if we go in the proper definition, what is defined by I mean, what is digital twin is defined. Okay, so if you see just the highlighted words, it's a set of well aligned descriptive and executable models. Okay, so these models, you might have heard about that. Okay, people used to do a set of simulations before doing something. Okay, Dr. Monali mentioned that I have worked on simulation based testing of autonomous vehicles. Okay, so in that project, before, I mean, as an autonomous vehicle, we cannot directly deploy the vehicle on the road and we can test it, so we cannot do it, okay, on the road physically. So before testing the vehicle, how much accurate it is, how much it is collision free, so before testing on the physical road, we should test in the virtually, like on the software based testing. Okay, so in that case, we have to create a digital copy of an entire scenario. For example, I'm trying to test the autonomous vehicle on a village road, or maybe in a city road. Okay, so we have to create a map. There should be buildings, or there should be roads, there should be pedestrian, there should be people walking on the pedestrian, a couple of vehicles on the road, signal systems, and the turnings left, right, everything we have to design first. Okay, so this is also could be a digital copy of a particular location. You might have heard, you might have played the GTA game. Okay, so there are a couple of real places that is copied in that GTA game. Okay, so like that, everything we can imagine in future is going to be digital. Okay, so that is what basically digital twin, and it should be semantically linked collection. It should not be like I'm putting a rocket engine in the middle of the road. We cannot put that. Okay, it's not semantically correct. We should if we want to put something on the road, it should be either vehicle or maybe pedestrian. I mean pedestrian in the means of people or something like that. Okay, we cannot put a rocket inside in between of the roads. It should be semantically linked collection. Okay, and for this example, if you see, we can there is a blade in the engine, in the aircraft engine. Okay, so we cannot put a bullock cart virtually inside that engine. That's not what it is semantically meant. Like semantically it should be correct, it should be relatable. Okay, so like that, it's a digital twin for any physical asset. Okay, so this is what the actual definition, bookish definition, you can say. Okay, so there are different types of digital twin. Okay, it could be a product type. I mean these are the main major types of a digital twin: product, production, performance, and executable. Okay, so I'll get into details of each and every one. So first go with the product twin. So product twin is like the image you are showing in the seeing on the right side is actually a product twin. Okay, it's a product. The aircraft engine is a product. Okay, it is actually used in real time, a real life asset, or a product inside a aircraft. Okay, so this is a copy of exact copy of the physical product, that is a aircraft engine. Okay, so this is defined as a product twin. So if you want to ask like what it is, what it will do if we create a product twin. Okay, so if you want to see like for this example only, I'm saying there is a aircraft. Okay, so now we have designed a very I mean durable engine, aircraft engine. Okay, now we want to verify that, okay, does this engine suits in the, or easily, or maybe you say can be attached to that wings of the plane or aircraft. Okay, so we cannot pull this heavy engine and we can go and put it there and just check on the go. Okay, so before that we can create a digital copy of it, of that particular engine, and we can create a digital copy of the plane, and we can see, okay, can I fit this particular engine into that into the desired place. If something is needed, okay, we can add a extra screw, or we want to cut this part to just fit it properly. So like that we can make use of a product twin. Okay, now moving onward, there is the second type, that is a production twin. Okay, so for production twin, if I mean there are product manufacturing companies. Okay, before installing their manufacturing hub. Okay, they should simulate it virtually. Like for example, in this example, if you see, there is a conveyor belt kind of thing is shown digitally. Okay, so before actually putting that component inside that particular location or particular geometry, we should simulate it. Okay, is it possible to put it there, or is it the viable thing to put it there? I mean it is cost effective or not, it is it is able to produce a much more rate, or it should produce the products very well, or it should not be faulty. Like that, multiple things are there we can verify putting a production twin. Like entire plant we can design in a digital twin. In the CIMIT, there is a product called CIMIT, SIMIT, from Siemens, so which is providing you before installing a real time factory. Okay, so for example, you are putting a factory which can produce say for example shoes. Okay, so before production of that actual physical deployment of that particular factory, okay, you want to verify, okay, we have a 100 meter area, for example, I'm just saying. So can I put some particular things in a place, like, okay, we have manufacturing plant designer who will give us a plan. Okay, you can put the boiler here, the leather cutter here, or the conveyor belt here, the stitching machine here. Like that, he has given a plan. Okay, now we can use that software or any other software, digital simulation software. So we can put that components, the conveyor belt, the virtual component I'm saying, the conveyor belt, the shoe cutter, the stitching one, the boiler, the whatever, the electric meter, everything we can put it as per the plan. And we can do a small simulation, okay, like that. Okay, from here the leather is coming up, and that is getting fresh, and that is getting cut, and the upper part of the shoe is made, then the lower sole with the plastic or whatever material it is being made, then it is went to via the conveyor belt and went to a machine which is packing that particular shoe. The other part of the product plant can verify whether the shoe stitching and everything is fine or not, otherwise it will reject the product. Like that, every entire scenario can be simulated using a simulation software. So for that, we need a digital copy of entire plant we are trying to build. I mean, we are trying to put it in physical world. Okay, so for that case, we need a production twin, so that which I mean, whatever we are planning, it is the best one. Or if any modification is needed, we can do it virtually without moving the heavy equipments or heavy components here and there in the physical world. So it is giving an edge to reduce the cost, the optimization, actually basically optimization of the plant planning, okay, or factory planning, you say. So in this case, the production twin comes into the picture. So moving onwards, so the next type of this is the performance twin. Okay, so performance, for example, the factory example I am saying, the shoe manufacturing plant. Okay, so that particular plant, we have a lots of components. Okay, whatever I mentioned, like stitching component, leather cutting component, conveyor belt, boiler, or product testing component, everything is there. Okay, so every component is generating some data out of it. So in that machine will have different kinds of data. Okay, so using that data, we can analyze, okay, is there any optimization we can build on it, or any component failure is there, or anything, any data analysis we can get using that data, using the performance digital twin. The entire twin gives us the overall data, and we can say, okay, this particular part we need to improvise, or if we want to, if we can replace this component with some other component, we can increase the production and reduce the cost, and it should be time effective. Like that, every analysis we can do using performance twin. So in the example, if you see that, the picture on the right side, if you see, then it's a picture of a plant which is each component is generating a couple of data, and that data is being transferred to some central servers, and those servers are using different algorithms, AI, machine learning algorithms, or any other statistic analysis, and from there they are getting some conclusion. Okay, everything is perfect, or what part of the data plant need to be what is called recalculated or restructured in a way, so that we can get optimized result out of it, optimized production out of it, or manufacturing. Okay, so this is all about the performance twin. Okay, now let's get into the executable twin. So this is the fourth pillar, I think, the of major components of digital twin. So the executable twin is basically, as you can guess from the name, that we can execute the particular twin. So the example I have mentioned, okay, a shoe manufacturing company. So before putting the exact replica of that particular manufacturing plant in physical world, we can build a virtual model out of it, and we can execute them. It should be like executable. Okay, it's not like that, okay, I have put for example 6-7 components of a plant. I'm just saying, a shoe manufacturing component plant may have 6-7 components, just for the example, and we just putting here and there, and trying to find out which is the optimal place for that particular component. But it should be executable. I just put it, I cannot connect the conveyor belt with the boiler, because boiler is used to boil a water, which can be used some other purpose, but it should not be connected with the um, say what conveyor belt. Okay, so the digital plan should be semantically linked. Okay, in that case, the semantic thing comes up. Okay, we cannot do these things because it's not possible in physical world. It should be the digital twin is basically a physical copy in virtual world. So it should be possible, whatever we do in the digital twin or digital planning or whatever we say, that should be possible to implement in physical world. It's not like it should be, that's why the word comes semantically linked or semantically correct it should be. Okay, so now the executable twin is that, okay, we have 6 7 components we have connected with each other correctly, that is a production twin. Okay, now we should be able to execute it, and in which direction if you ask. Okay, so in executable, if you say, okay, I am putting some 10 feet by 10 feet of size of leather on a conveyor belt, and it is going into some cutting machine, and that cutting machine have some particular for example, I'm saying there is a motor and there's a knife connected to it, and it should cut in a particular size, for example 2 feet and 2 feet by 10 feet, like that. In that size, it should cut the leather into multiple pieces, and it should go to the particular, for example, stitching machine. So it should stitch in a particular, for example, the stitching should be uniform. It's not like the gap between the stitching should not be like in some cases 1 inch and some cases 2 inch. It should be like if I'm considering 1 inch of gap, so it should be 1 inch of gap in for all the stitching points. Okay, now the packaging component, for example, so that packaging component should consider 2 shoes in a one box. It should not consider for one case it is considering 1 shoe in a box, and the other case it is considering 3 shoes in a box. It should not be the case. Okay, so that particular performance has to be tested using the executable twin. So if you see for example, if a boiler component is used in the particular digital plan, for in the example, if you see, so this is the snapshot of a Siemens software, that is SIMIT, SIMIT, SIMIT. So there is a my pointer. Okay, so this particular box, okay, the edge, I mean round edged box, this is called a boiler. Okay, so this boiler has this is a meter. Okay, this meter shows that how much water or whatever liquid it has into it. Okay, so if you see the this is the blue, if you are able to see, there is a blue mark at the bottom of the indicator. So if you see this much amount of liquid inside this particular boiler, so and this shape is called a valve. So there is a valve connected to this boiler, which can be used to either inlet of the liquid or the outlet of the liquid. Okay, so this I'll show the bigger picture. Okay, so I think it's visible now, better now. So so this is the tank. Okay, and this is the indicator, and this small this shaped as are the bulbs, basically, if you say knobs or tap, like that. Okay, and these shapes things are like the instrumentation functions. If you say instrumentation, what is like that? Okay, so this black, the whole black thing is a digital unit, which takes as an input, analog input or digital input, that what kind of data it should flow, or at what pressure it should flow, at what temperature the liquid should flow, like that. There are multiple things we can assign some formulas to it, like, okay, if the liquid is flowing in that particular rate, then the temperature should be a particular temperature, for example T. So we can assign multiple formulas to flow the liquid inside it. If you see, there's a this circle is a heat node, this circle is a pt is for pressure temperature node. So we can give an input to this pressure temperature node. Okay, I want 1 atm of pressure and 10 degrees of temperature in that particular node, and if you want to increase some more heat, then we can add 10 degree 20 degree more into it, or like that. And if you want to pass through this pipe, then there is a digital connector here. So there's an instrumentation function connected to it. Okay, if this particular condition follows, then we can add extra for example pressure onto it. Okay, so for example 1 atm pressure can be supplied to this pt node, and I need to increase the pressure of that particular liquid flowing inside that pipe. So we can assign some formulas into this particular function, instrumentation function, and we can pass this entire thing into this valve, that okay, this valve is connected to control the liquid flow, either I want to flow it into that this particular tank or not. So like that, we can assign multiple valves into it. So there's a lot of components we can see here, like that. it's a very simple plant model with a single tank and multiple input output nodes and multiple inlet outlets, and with a couple of instrumentation functions having the formulas and like that. So very simple thing, and it can be very complex, as you can imagine. The big manufacturing hubs, the big you say delivery partners, a big transportation things, the aircraft system, everything is being in digital copy of physical world. And before the actual deployment, it should be properly tested, properly simulated, so that everything is fine on the real world. Whatever we can visit possible in the physical world should be tested in the virtual world using digital twin. I have worked for autonomous vehicles, so we have used two different kinds of simulations. One is uh, uh, simulation based testing. I have used, sorry, we have tested in two different ways. One is simulation based testing, one is RL, reinforcement based testing. So what we did in a very broader way. So before in simulation based testing, what we did, like we have different collision scenarios. Okay, our vehicle can collide in this particular scenario, like our vehicle is going on the road, and there is a pedestrian, if, for example, people in between the road. Okay, so whether the vehicle is colliding or not, vehicle is passing other way or not. So every scenario, executable scenarios, we can imagine in this particular platform or any other simulation platform. So that it can be tested, tried and tested, so that we can deploy it in physical world. So these every simulation tool to I mean tools we are using in the real world, I mean in the current industry domain. So everything has a executable twin of a physical replica, physical entity, if you say. Okay, so this is what the executable twin. So now, if we go, the what are the use cases of digital twin? So use cases means like what are the applications of a digital twin? So I just mentioned at the beginning of this session that okay, whatever we are going to imagine is going to be a digital twin in upcoming 10-20 years. Okay, I think you might have heard about the industry 2.0. If not, then you might have seen the ad from Dubai Expo. Okay, so done by Mr. Amitabh Bachchan. So all the fairs, all the if you have, I'm not sure whether you have attended any of the session of Dubai Expo. So that particular expo having was organized to showcase what the capabilities of current technologies we have. So one of the technology we have is digital twin out of them. Okay, so if you see the metaverse thing is coming up. So metaverse is based on multiple complex technologies including augmented reality, virtual reality, mixed reality, extended reality, AI ML algorithms, cyber security, and then optimization algorithms, then data analysis, and performance, everything. It's a combination of whole lot of technologies into a metaverse. Okay, if you see, right now we are like buying on the Flipkart or Amazon kind of applications. Okay, so we are seeing, okay, these things are like, okay, it looks good, so we are buying it. Okay, now in the upcoming future, maybe down the line 5 years or 7 years, if you see, you will have a and right now if you see that, okay, the Mintra app used to ask you, look, okay, whether you are buying it for you or someone else. If it is if you are buying for you, then you just mention it, and on the right, on the other product, it will show you that whether it suits you or not. So it's a kind of intelligent system it is they are going to build. Okay, so now in upcoming future, they are going to be metaverse based shopping. Okay, so you'll have your own avatar in your digital world, and if you just upload your avatar with your shoulder size, waist size, chest size, and you just upload it in your metaverse, in their metaverse, or whatever they will provide. And then you will be able to check for example, you're buying a shirt. Okay, so that particular shirt you will be able to try and test on your avatar. Okay, that particular shirt suits you or not. So these kind of things are going to come up, and people are going to be more on virtual in than in physical. It is predicted. Okay, and right now if you see, people are more addicted to the social media, so like that people are going to be more aligned towards the virtual world, a virtual reality of the physical world. Even people are going to do business, people are going to do job, people are going to do advertisement on the metaverse, on the virtual world. Okay, you will be able to earn in the virtual world, you will be able to make profit, make even the equity, everything. There's a possibility that it is going to be in the virtual world. Okay, and if you see, the next point is like product lifecycle management. Okay, so now you have build and product. It can be of a software based product, it can be a hardware based product. So hardware based product I have already explained to you, like like this example, the aircraft engine, or maybe any manufacturing unit you can assume that is going to be useful using the digital twin techniques. Then in the software field, if you see, before it's although it's already in digital form, still we'll be able to make use of that particular digital copy of that particular software. Some other device or other team can work on it, like what optimization we can use using the data analysis and all these things. Okay, so throughout the product lifecycle management is going to be very useful. Then industrial simulations I already mentioned on regarding this, like for a lot of things we are already simulating, and we are already working on it for other simulations like autonomous vehicles, and whole lot of things. Then supply chain is also a part of it. Like you have for example, you are trying to trying to open for example, transportation company. Okay, inside say Bangalore. Okay, now you have the entire map of the Bangalore digital. You have just created a map, digital copy of entire Bangalore, and all the roads and all the highways you have already mentioned on your map data. Now you can simulate it using digital twin, and you can find the optimal path to put your warehouses. Like at you have for example, say five you want to put 5 warehouses inside the Bangalore. So it should be placed in a way that it is optimized to the cost, as well as you can deliver the products as much as quick as possible. Okay, so in that case, you need to build a digital twin, and you put some optimization algorithms on it, and you can get the best out of it. Okay, even the healthcare domain also, people, all the doctors, I mean, some companies are already working with the doctors, so that we can put a virtual you say presentation to some patient, like, okay, I want to put a, for example, I want to do a what is called a CPR, I think, when people get stroke. So people will be able to show you, okay, like do
CPR.
things like that. Sorry.
Yeah, it's CPR actually. Yeah.
Yeah, thanks Monali. So things like that we can achieve using digital twins. The manufacturing companies I already mentioned, all these thing companies are already using digital twins. Okay, then asset virtualization, the example you are seeing, the product twin, basically the asset virtualization. We are viewing a digital copy of a aircraft engine. Okay, so like this, a lot of things are already possible using digital twin, and it is going to be in future very soon. Okay, so we cannot count on like how many use cases or applications we can get using digital twin. A lot of applications are there. Okay, so this is all about what digital twin is and what we can get out of digital twin. So I mean, if anyone have any question, we can regarding this digital twin.
Anyone having question, you can ask.
Students, you are open to ask any questions. Please ask question. It was an interesting topic by Mr. Verma. So please, I ask you all to even interact or have any other questions related to this topic, you can really ask. Yes, participants, any one of you with you can come up with any question regarding this, or if you have not understood something, you can again just
Yeah,
ask to
definitely.
repeat that.
Or it totally bounced up your head. That also you can say. I can repeat few things if you want.
Many students are here, like Gautam, Kartik, all of you are there. Like you all can ask something.
Okay, fine. You can go with the second phase.
Okay, sure. So the second phase of the presentation will be application deployment. So it's totally a different topic than digital twin. So just keep your mind freshen up and just pay attention to this particular topic. Don't link it to the digital twin. Okay. So
And last time, actually, people were not able to unmute themselves, I guess. So I've
okay,
allowed them to
sure.
unmute. Yeah. If anybody now, if you want to unmute yourself and ask, then we can. If anybody has still questions to ask, you can ask. I've allowed you all to unmute yourself.
You can also use the chat box.
Yes.
You can also use the
Okay.
chat box.
Let's get to the chat box.
No questions. Okay, let's just then proceed further.
Okay, sure.
Yeah.
I think people are getting tired of their classes.
Maybe. Okay. Okay, let's
Okay.
thank you. Yeah, so
Okay,
the thing,
Okay.
I
can
have a
we assume?
question.
Yeah, we have a question
Can
from
you?
Akash. He's saying, can we assume digital twin as a copy of any hardware machine?
Yes, yes, Akash, we can assume, even not assume, we can build a digital twin of any machine, any hardware machine you can imagine, or in today's world, any factories, manufacturing units, everyone using this digital twin to simulation before the physical deployment and everything.
Akash, any more questions from your side? Students, participants, you can just unmute yourself also and also put a question on the chat box if you have any query. No. Okay, fine. Okay, he's asking,
Uh,
it's like a simulator.
Uh, yes, but not exactly the simulator. We can use the simulator to simulate on those digital twins. Simulator is a software which allows you to simulate the digital copies you have already built.
We have another this one from Charan Sai. So he's asking, how can a digital twin be built up?
Okay, so that's a nice question. Digital twin. For example, I'm saying with linking to the earlier example I mentioned. So if you go to, is my screen already shared or?
Yeah, it's already shared. No. The screen is not shared. I think, are you opening all the students this list? That is shared now.
I mean, I think.
I think it is shared. Yeah.
Okay, so just let me know.
Are you sharing any PPT or like the whole?
Yes, I'm sharing a
No,
slide.
the PPT is not visible.
Okay, let me share it again. Yeah. Yeah, I think it is shared now. Uh, is it shared?
Yes, it's
Yes,
shared. It's
you
shared.
can see it.
Okay. So in this example, the simulation you were saying, like Akash, the simulator. So for example, this entire change the pointer. So okay, so this entire software you are saying, this is a Summit software by Siemens. So this software Summit is a simulator, okay, and inside that we have built a digital copy of our of a plant, okay, that we are simulating. Okay, now how to build a simulator? Okay, so for example, this is the tank. Okay, so in physical tank, just imagine that there is a tank. In very layman term, just think of a tank in your home. Okay, there's a water tank in everyone's building. Okay, so that particular tank has a particular diameter, has a particular height, has a particular volume, has a particular capacity, has a particular a number of inlets, has a particular number of outlets for the water. Okay, so this is a physical tank, and we can build a tank of a physical tank to the virtual world having the same properties. Okay, this is just the bounding box to show, okay, this is the particular tank I am building. So for that particular tank we have the particular properties. Okay, the diameter should be this much. Okay, the length should be this much. Okay, the area, the volume, the number of inlets, the number of outlets, the rate of speed of inlet of that through because the inlet pipe has some hole on the tank. Okay, so that hole can be of 10 centimeter of diameter or 20 centimeter of diameter, so that particular pipe should have a particular rate of capacity to fill the tank. The outlet pipe has a particular diameter, so that particular hole should have again say 10 20 30 centimeter of diameter, so that the water flow should be the outlet should be through that outlet at a particular rate. So all the properties of a tank, as well as the dimensions, as well as the capacity, everything can be the properties of a tank, which can be simulated using this simulation software. So in this way, like putting like this bounding box, I'm just assigning here that is the tank and it has so and so properties. So in this way we have the digital copy of that of this particular physical tank with in this case the indicator. Also we have the how much liquid it has. So in this way, we can build a digital twin of a physical asset or anything. So am I able to clear your doubts?
Yes, Akash and Sharon. Yeah.
You can unmute and ask now.
Okay, Akash, it's yes. Thank you so much.
Okay,
Sharon,
welcome.
Sharon, is your question like answer? Like, are you clear now?
Any other
Uh,
questions?
okay, Sharon saying not being a joke, the digital twin is just like a virtual image of a machine.
The image is different. Okay, so you can click a picture and and you can upload in some software that is different. That is just a image out of it. But digital twin has much more capabilities than image having a say 2D image or 3D image, because I just mentioned, right, you can have a different set of properties for a given component. The thing I have mentioned, that okay, you have a tank, so you can click a picture or 3D image and you can upload in the simulator. Okay, this is the tank, but this tank is of no use if we want to go to the simulate it, if we want to simulate a particular scenario. Okay, so the tank should have the properties to, for example, say number of inlets of water or any liquid, or number of outlets should have, it should have a particular volume, it should have a particular capacity, it should have a capacity of holding a particular temperature of a liquid. So in this all of considering all of these properties into one, including the image of 2D as well as 3D, we will make the digital twin of of any machine or any physical asset. So am I clear to you, Charan? As it is feasible, as it is movable. Uh, can you elaborate a bit? Yeah, it can have motion too. Like if you if you want to simulate a vehicle, then it should have a motion. It should have a whole lot of properties in the physical world. Everything can be in the digital world. So anything, I mean, you cannot say that okay, the tank has a motion. It's not like that. Okay, it's illogical. It's not semantically correct.
Any more questions? Uh, I guess there's no more questions, so we can proceed further with this session.
Okay, sure. So then let's get into the application deployment. Oh yeah. So application deployment, in a nutshell, it's a part of application development lifecycle. Okay, or say product development lifecycle. So this is very important, and the technologies we are getting nowadays, it's very making you very comfortably to write your code to deploy an app. Okay, it's very easy as compared to the earlier it has to be. Okay, there is a saying, it's not saying, the monolith is going to be in microservice. Now you might wonder what is monolith and what is microservice. Okay, so initially, the softwares, if you imagine I mean, for example, say 10, 20 years back, the softwares were monolith. Okay, monolith means every component is packed into one single container. Okay, container in the sense like you might have heard the software backend, software front end, software testing, software deployment. So everything was inside a single unit of software. Okay, and now it has a very what do you say, um, uh, disadvantages, I say. So and what sense the disadvantages? So the disadvantages are in that sense, like if you want to edit or tweak a particular feature of the software, then it might be possible that we have to bring down the entire software, or if it is cloud based or some other based, then you have to hamper the entire software to edit that particular tweak. Okay, but nowadays the concept is called microservice architecture. Okay, microservices, the word is saying micro, that means the big software, this, for example, a very common example, Flipkart. Okay, so Flipkart, I'm just roughly saying, it's not the actual architecture. I'm just roughly saying it has a order management system. It should have an asset management system. Asset management, like how much product it has, how many quantities of a particular shirt it has, how many quantities of a particular say furniture it has. Okay, asset management. One could be like delivery management. For example, I'm just considering these three only. Okay, so asset management, order management, and delivery management. Okay, so initially, if you see, earlier softwares were combining all these three things into one unit. Okay, so if we used to edit one something in say asset management, then I have to bring down the whole software, because that is combined, bundle into a single unit. So I have to wrap up the sorry open the entire unit and change, do the tweaks, then I have to bundle it again. Okay, so in this way it used to be. if you want to change a small tweak, you have to do I mean, you have to hamper the whole lot of services. Okay, but now the microservice things come up, so it has the concept like you just separate all the services as an individual entities. Okay, so the example I have shown, I just said the asset management should be different, the order management should be different, and what is called delivery management should be different. So there are three different entities, and each are connected with each one of them connected to each other, so that they can talk to each other. Okay, so we have three, if you see, we have three nodes. Okay, and at 3 points with a triangle, so they are bidirectional communication between them. Okay, okay, so if something happens in delivery management, okay, so this particular delivery is cancelled, so that same thing will be updated in the asset management. Okay, this asset management at that particular time might have 10 number of say shirts it has, but one shirt get cancelled by the user, then the automatically the count should be 11 now. Okay, so like that it has, I mean, on in nowadays softwares are totally microservice based. Okay, each and every service, each and every component is different. Okay, and they are individual entities. Okay, so among that, if you want to bundle up all those things, and if you want to deploy it, so that initially the user was very less, now the user base has grown huge, in exponentially it has grown. So in that case, if you want to do it proper deployment with the microservice architecture, so in that case the application deployment is very crucial thing. Okay, so you might have heard about aws has a lot of things, lot of deployment components. Okay, you can use these things, you can use ec2, you can use IAM roles. You can use AWS Cognito. You can use API Gateway. A lot of components they have. I mean, AWS has provided to deploy an application. So like that, you have Microsoft Azure. We have Google Cloud Platform. So these are the platforms where we can make use of the deployment tools if you want to use them. By the way, okay. So so the whole concept of being developing an app is to make it available to the user or the end customer. Okay, so how we are going to deploy those things, that is very crucial, because for example, flipkart, uh, I'm roughly saying, okay, there could be hundreds of crores of API calls to the Flipkart server, okay, in a day. Okay, so those many calls should be managed efficiently, so that app doesn't get crashed. Okay, so like that, a lot of things are there in the application deployment. Okay, it should be optimized, and it should be cost effective as well as, and it should be available to the user 24/7, because you might never you might have faced for a seconds or minutes of crash in Flipkart, and sometimes during the sales and all, but Flipkart is 24/7 accessible. Okay, how they are managing those servers, how they are managing those cloud solutions to handle these many of traffics and these many of data they are handling. So all the things that comes under this application development. But I have a very what's a micro part of the application deployment, just to present you from where it begins. Okay, so there is a concept called Dockerization. I'll just start with that, because that is the base of application deployment nowadays. Okay, so if you see, these are the major stages of application deployment, because there are multiple stages inside it of a software application, from planning to deployment, okay, to monitoring. So initially we have a plan. Okay, I want to build a particular app. Okay, I'm just, for example, I'm saying I want to build a something like Flipkart. Okay, so we should have a plan. Okay, we have these many services, like I just mentioned. We can have asset management server, we can have order manager, we can have a delivery management. Okay, and all those architectures we have drawn. Okay, like that we have plan everything with there will northbound communication, southbound communication, like that. These are the terms people use, but don't get confused. So just we are trying to build the architecture, a plan of a particular application. Okay, now we'll start with the building the application with the automations of the applications. Okay, so that the next step comes under the continuous integration and continuous deployment. Okay, so that is, in short, people used to say CI/CD pipeline. Okay, it's a pipeline. This is the part I'm going to focus. Okay, from the grassroots level. And after that, this app testing comes up, a lot of unit testing, a lot of rigorous API testing, everything goes on. And then after that testing, it goes into the deployment phase, and then testing as well as this CI/CD pipeline, everything comes out of the deployment phase. Okay. And then the monitoring starts, like whether the new feature that is added is it crashing, or anything else that is happening, or data they do, people in the big companies do the data analysis, like what particular product is going to be used very much, or what particular product is not used nowadays. If you have noticed that Zomato has started advertising couple of restaurants. Okay, you can order from this, because on those restaurants might have paid well to Zomato to add their hotel or dhaba, whatever it is. So like that, they do the data analysis, and they show the customers, okay, these are the people, these are the services you can use in this app. Okay. So we'll just stick to that for now. We'll stick to that, the CI/CD pipeline. So this continuous integration and continuous deployment. Okay. So sometimes people used to say continuous integration and continuous delivery, and sometimes people say continuous integration, continuous deployment. So now what is this continuous? Just give me a moment. Let me silent my phone. Yeah. Sorry for the interruption. So the continuous integration and continuous deployment. So what are these things? Okay. So continuous integration. I'll start with continuous integration. So integration. See what in industry, what the methodology we follow is agile methodology. Okay. You can Google about it. It's not a big thing. Okay. So there is a pipeline. Okay. The developer has in very layman's term, I'm saying. Okay. A very typical company do, I mean, developer tester company do like that. Okay. We have a particular say feature we want to build. Okay. So the plan has come from the architectures. Okay. Architects, the plan has come. Okay, we have to build these components, these services. So the plan has come to the developer starts building the code, building the feature, writing the code and automation, everything he has written. Now the testing comes up. Testing team, they'll write some unit test, API test. There are multiple lot of testing codes are there, so they'll try to test the code that has been written by the developer. Okay. So this integration goes on pipeline. Okay. I'm not sure whether you have read the operating system pipeline thing. Okay. So it happens like feature, say for feature 1 we have A B C D E 5 different units. Okay. So a feature is developed by the developer, then testing team starts testing it. In the meantime, the feature B is already started by the developer team. Okay. By the time a feature is being tested by the testing team, the B feature is already available to the tester to test it. Okay. Then C particular component is being developed by developer by the time testing team is testing B component. Okay. So now the B component tests are successful, then C component come to the tester, and then D component starts in the meantime D component starts getting developed by the developer. So like that pipeline goes on. Okay. So this continuous integration between the development as well as the testing, everything, all these things comes under this continuous integration. It's an autonomous process. You have written a couple of development code, a couple of testing code. You just give the code to the CI/CD pipeline. It will start doing all the integration, testing and everything autonomously. Okay. So this is called it's an integration between development and testing automation. So it's called continuous integration. Now I'll start with the continuous delivery, then I'll come to continuous deployment. Okay. So the continuous delivery is like uh, if you say after the everything CI is done, like automatically building the app as well as testing the app, everything is done. Now we have to deploy to some servers. Okay. To make it available to the end users, to the end customers. Okay. So to deploy an app to a particular server, we have to write a couple of scripts, couple of codes and all, so that we can on a click of a button, on a click of a single command, we can deploy the entire application. So that is called continuous delivery. Okay, in between that, continuous CI also runs on that. Okay, the building testing is going on, and by the time we can deploy the feature to the production. Okay, so that's why it is named as continuous. Okay, now continuous delivery, this is the concept, and on a click of a command or click of a button, you just deploy the feature to the production or whatever the desired server you have. Okay, now deployment is a little bit different, because in the continuous delivery, people there is a human intervention. Okay, we have to run a command, but in continuous deployment everything is same. You just don't have to there is no user interference between them, because you don't have to write a single command. Everything is continuously deployed into the servers. Okay, now so people used to use this continuous delivery and continuous deployment both in the case of CD. Okay, but CI is something different, and CD is for like deployment or delivery, both are the same. Okay, so now I just mentioned that. Okay, everything nowadays is getting containerized, because in the cloud services, people, I mean, even big companies are making their own softwares cloud based. Okay, because nowadays there is no concept of, I mean, people are preferring cloud based solution as compared to your say client based softwares. Okay, so now if you have an option, okay, for example, say if you have an option to install the Microsoft Office in your system and writing whatever, for example, making a PPT out of it. Okay, but you have another option to go to your browser and just open office.com, log into a Microsoft account, and you can access all the features you have in your client system. So I think 99% of people will prefer to go to the cloud services, because you just need any devices you want, because for Microsoft Office you need to have a certain hardware, a certain RAM, a certain memory. First of all, you need to have. Okay, to install that client software into your system. So it takes your memory, as well as hard drive storage, as well as some amount of RAM, as well as some computation power. Okay, but if you switch it to the browser, you will need to have a browser, Chrome, Microsoft Edge, or whatever Firefox you have, you want to use. Just choose your browser and go to the office.com and do whatever stuff you want. Okay, so it's very very convenient to use for any people, like instead of having a standalone client level softwares. Okay, so everything has to be available on cloud in upcoming future is going to be. Okay, so for that, the deployments, people has introduced the Docker concept. So now the Docker concepts are like, uh, you might have heard of having a term like, ये तो मेरे में चल रहा है ये code, like this code is running in a machine. I'm not sure why it's not running in your machine. So people have faced it and have complaints. Okay, in IT field, developers say, okay, this code is running in my machine, I don't know why this code is not running on testing machine. Okay, so there is always a quarrel, I mean, cold war between the developer and the tester. Okay, so uh, this is the very what do you say, very important problem that Docker has resolved to the current IT field. Okay, so there is so what I'll just get into the Docker. So just keep in mind that, okay, the Docker has resolved the problem, that is, people, there is a saying that this code is running in my machine, I'm not sure why it's not running in your machine. Okay, so they just throw away things like that. Okay, just they shake their heads and just say that, okay, you just think of, I mean, you try on your machine, I'm not sure why it's not running on your machine, it's running on my machine. Okay, so what Docker has come up with, so it's basically a virtual machine. Okay, of in very nutshell, you see, it's a lightweight virtual machine. Okay, on the left side, sorry, on the left side, this is a structure, or a very broad view of a virtual machine concept in our system, and on the right side, it is the Docker. Sorry. So if you see the very bottom level, we have infrastructure, laptop, servers, or cloud, and there's a host operating system, basically our installed operating system, maybe Windows OS, Windows or Linux or Mac, whatever you have. Then there is a hypervisor. So hypervisor is basically say a software which enables the operating system to run another guest operating system to the host operating system. Okay, so this works as a middleware between this guest operating system and the host operating system. So VM is like we are trying to run Ubuntu inside a OS, inside Windows, so kind of thing happen. Okay, this is what concept of VM. So so on the host operating system we have a middleware hypervisor, and we can have multiple VMs like that. Okay, so we can have for example, I have shown here 3 VMs. So we have guest OS 1, guest OS 2, OS for operating system. So guest OS 1, 2, 3, and inside that OS there's 3 different applications and running on. So this is VM1, this is VM2, and this is VM3, as it is clear from the picture. Okay, by the way, if you have any doubt, you can stop me in the middle. So I'll happy to answer that. Okay, so now okay, so this is the basic structure of a virtual machine. Okay, so now what's the problem of this one? So that we have to introduce the Docker. Okay, so one problem is that I have mentioned that okay, it is working in my machine, I'm not sure why it is not working in your machine. So people started using the VM. Okay, so what a virtual machine is, for example, I have an application, so it has some dependencies for to run the program. Okay, in some cases say what say okay uh, so for example, Flipkart. Okay, so Flipkart it needs to know your location, or say Google Maps. So Google Maps, very easy to understand. So we have a Google Map. So you have to enable your location, so that it can tell you that at particular location you want to go, what is the optimized path to go. Okay, so you need to enable your location. Okay, so there is a dependency to run the Google Map in your phone or any device. Okay, so if that dependency is not met, is that if the dependency is not enabled in your device, it will not work. The Google Map will not work. Okay, so like that, in every application there are they have their respective dependencies on that to run that app. So if that particular dependency is not met, the app will crash, or it will not run even. Okay, so that's why we have one host operating system, and we have installed a guest operating system with those particular features or dependencies enabled for this particular app. Okay, in the VM1. Now I have different I want to test different other features, different operating system, different application. So I have to build another guest OS, and with those dependencies enabled, that is needed for application 2. Okay, for this VM2, like that for VM3 also. Okay, so now if you see that we have one host VM, and inside that we are running another 3 guest OSs. Okay, so that is a huge cost. Okay, in terms of computation, in terms of power, in terms of time, in terms of complexity, in terms of resource allocations. Okay, so this is the infrastructure we are having. Okay, so now if you see, for example, right now we are running 4 operating systems. So you just imagine that the amount of RAM it needs, the amount of storage it needs, the amount of computation power it needs. Okay, so this is very highly costly. Okay, now the Docker has resolved to the other thing, that we have same infrastructure, we have same operating system. Inside the instead of that hypervisor, we have a Docker engine. Okay, so this engine is again middleware between your host operating system, for example, say maybe Windows or Linux, whatever it is, and it has a individual containers. These green boxes are called individual Docker containers. Okay, so container is basically like this. Okay, so VM you have. Okay, so not exactly VM, a container, you can imagine that. Okay, I have an application with those features enabled, and I can run it independently in a container. Okay, I'll just show you in the demo what actually container is. Okay, so we can run different applications in different containers. Even these containers can speak to each other. So I have mentioned, like, okay, the example of Flipkart. Okay, a similar app to Flipkart, that we have asset management service, we have a delivery management service, we have order management service. Okay, so you can deploy your asset management in one container, delivery management in another container, and the say what was that there? Order management in other container. Okay, and you can make a communication between define these 3 containers internally. Okay, so you don't need another guest operating system for all these individual applications. Okay, what is needed in virtual machines. So it is very lightweight. It's very lightweight as compared to the concept of virtual machine. Okay, so that's why people used to prefer this Docker containers instead of the traditional virtual machines. Okay, so this is optimized, this is cost effective, this is less resource usable, and whole lot of features Docker has. Okay, I'll mention a few of them, and if you want to know more about it, you can directly go to the Docker official website. You can know a lot of things. Okay, so till now, anyone have any doubts, because this is a very new concept?
Any questions? You can post in the chat box.
Yeah, that's also fine.
So by using microservices alone, can we reduce the cost of server?
It's not exactly we can reduce the cost of microservice. I mean, cost of microservice using the cost of the application using microservice. There are a lot of dependencies on it. For say the traffic management is also one, the SSL security services, that is one. So a lot of things are there to handle the cost effectiveness. Microservice is one of the part of the reduction, cost reduction. And it's not basically for cost reduction. Microservice is mostly useful for resolving, or say coming out of that monolithic architecture. Okay, so we can have microservice instead of monolith, just to make the services independent, so that we cannot once we change or tweak one service, it should not affect the other services.
But microservice, by applying microservices, it also kind of increase the cost on the company, right?
Yeah, that also
Because,
increases the yeah.
So is it beneficial to kind of migrate every monolithic architecture to microservice architecture?
I don't think so, because monolith, the microservice is gives you edge over monolith, but it depends on the situation. Like say if you have a huge simulation software, so if you want to make it available on the cloud, so it is much more cost effective. Costly to the companies. Okay, so it depends on the software, depends on the solution you are providing. It's totally depend on the scenario, like whether if you want to if you go with the microservice, whether it will reduce the cost. But it gives an advantage over monolith that I mentioned.
Okay, all right.
Okay.
Mr. M, thank you for your question. If you don't mind, can you just give us your name, your introduction?
Yeah, it's Michael.
Okay, thank you so much. Thank you for your question. Any more questions from anyone?
If not, then let's we can proceed further. Keeping
sure,
time in mind.
Yeah. We have 15 more minutes for this.
Okay, so we
Thank
have. Okay, so how to containerize an application? Okay, so there is first you build your applications. Okay, whatever the base app you have, then write a Docker file to containerize your application. Then build a Docker image out of it, and you run the image to build a Docker container. So what Docker file is? It basically a simple text file having a set of instructions. I'll just show you in the demo. And then we have, if you run this Docker file, it'll have a Docker image out of it. So Docker image basically a set of binary instructions, a machine level code, and those codes and that particular image, the image you have built of your applications can be run in a Docker container. Okay, so it's just have a broader view that you have applications, you have your Docker file to build your Docker image for that particular applications you have, and out of this image will run the image in a particular container. The container I have mentioned, this is the app1, app2 is the individual container. Okay, so now let's get into the demo. Oops, sorry. Okay, so this is the basic what it is, application run. Okay, so this is a basic very simple application having a hello world written in Python. Okay, using the Flask framework. Okay, that is running on the 0.0 and port 8000. Okay, and we have a Docker file. Let me just open it. Yeah, so this is a Docker file, basically a text file. So if you see, we have a couple of keywords to write in the Docker file. It has a particular format and as a keyword. So there is a from which asks you, so this is the Python 3.7 image we are using. So this image is already pushed in the Docker hub, like GitHub and GitLab we have. So Docker has its own Docker hub, so that is open to anyone. So now if you we are using Python 3.7 because we have written your code in Python. As similarly, you can use the Ubuntu image, and you can install Python inside that Ubuntu image, and you can run your code. Okay, so we have from just to just this is the base image. On top of it, we will build your applications. Okay, so this is the label to maintainer, say my name Amrit, just to tag that who is the maintainer of this particular Docker containerized application. This is the work directory I'm creating, slash on the root hello up is the folder which will be used as a work directory. Then we are copying all the, right now we are in this particular folder, so all the component, all the file and all the folders will be copied to this hello world. So basically it will create this from Python 3.7. This will create your say a container of Python. Okay, inside that container will have all our code. This entire code will be there. I'm copying from dot is like is for source directory, and this slash hello app is for destination directory. So we are copying from current directory to this hello app in the source and destination container, and we are running a simple pip install. There is a couple of requirements. Only we have one Flask, this framework. So we have sorry, I think I closed the Docker. Yeah, so we'll be installing this requirements file inside that particular container. Okay, and we are exposing 8000 because the container is closed. Okay, and we want to communicate over a particular protocol and particular port, because every HTTPS connections made via port and an IP. So that's why we have mentioned here this IP, the default IP 0.0.0. Okay, and this is the port the application will run. Okay, and this is the expose 8000 is like we are exposing that 8000 number, the port number 8000 to the outside world, so that they can make a communication to the if you see, I just show in the PPT. Okay, so this is a single container. Now if you want to make a communication from, for example, say from this container or outside of some other container, or say in your from your host machine, from here to here, you want to make a communication, then it should have your one port open. Okay, so for example, I'm saying open port 8000, so that any other container, any other source can communicate on this app1 through a particular port. So that's why I have exposed the port number 8000, and we are running the command Python and the run.py inside this app. Okay, so first of all, I have mentioned that you have to build your app. So that's what we have done. So we have built our app. This is the basic app with the root access to, it will print only this much. Now we have to write a Docker file. So we have a Docker file, right? Now build a Docker image. So there is a simple command. I'll just show you. Okay, so this is the command. I'll just clear it up. Okay, yeah. Yeah, So this is the command docker build -t test1 dot. So docker build is the command. -t is to tag a name of that particular image, because if you don't provide any image name, it will create a random image name for you. And then dot is for the docker file at what directory. So we are in the this VIT-AP talk in this folder only. Oh no, so we have to get into the actual folder. Yeah, here. Yeah, so this one. So in the current directory we have this docker file, so you have to mention at what location the docker file is. Okay, so now if I build it, so see it has pulled the image, created the work directory. Yeah, so if you see it has, see if you see, this is, it has built the Python 3.7 image from its default directory. Okay, and then it has made the work directory hello app. This copied everything to hello app, then it has run the pip install the requirements file, and it has exported the image. Okay, so if you see here we have docker desktop. So see, this is the image we have got. Okay, so I have named the tag the image as test1. Now I have to run the image to build the containers. Right now if you see, there is no container running up here. Okay, so to run the container, docker run say -p 8000, sorry, 8000. Okay, see, okay, test1. So what I'm saying, I'm running the command of docker run to run an image of mine. -p is to give a port mapping. Okay, so this is the, on the right side the port 8000 is the exposed port of the container, and the left side port is the 8000 port of the host. So that has been mapped. Okay, if any connection goes to the 8000 port of this particular my machine, so it will communicate to the 8000 port of the docker container. Okay, and this is the image name. If you see, this is the image name we have given, test1. Okay, now if I run it, see, so this is okay, this is running on this port 8000. Okay, now just open the browser. Sorry, so the local host 8000. So if you see, so it has printed, I just show you separately also, localhost 8000. See, so we have the hello VIT-AP people. Okay, so that's what print we have mentioned here. If you go to the part, yeah, so if this is the method, it returns this one. So this is the basic simple very simple app which can be containerized. Now okay, now I'll just show you the container. So this is the image we have built out of our code using the docker file, and this is the container. I didn't mention any name to the container, that's why it has created a random one, and it is the out of the image test1, and it has a tag, like you can have multiple versions like test1 v1, test1 v2, like that, whatever you want. By default it'll give you, the system will give you the latest one, and status running, and it is running on the port 8000. Now I can show you the layers. Yeah, it's not opening up. Yeah, so if you see the image we have built, the test1, so it has it is showing the bottom up. So we have command we have written here, docker file. Yeah, see, we have a bottom up process. We have command python c, then expose, then run pip install, then cmd hello. So like that, it has layers of instructions to run on a container. Okay, and now I can show you. So this is the container, basically a very lightweight virtual machine it is running on. Now we can get into that container, open in terminal. Okay, if you see, let's see. So current, because we have set our work directory to slash hello app, so that's by default it is in the hello app. If you see, docker file, readme, app, docker compose, YAML requirements, everything is there. Okay, see, whatever structure we have here, we have in the container. Now if you want to see the pwd, sorry, so see, we have the hello app. We can go to root also. See, we are in the root directory. So this is a very lightweight. Oh, by the way, if you are using on Windows, you can switch between the Windows containers and Linux containers. There are different types of containers. Okay, see right now I'm using Linux containers, but you can use switch to Windows containers also. So then the OS the container will be of operating system type of will be Windows, but right now I have in Linux. That's why you can see that the structure, the folder that is preferred by Linux is here. Okay, so in this way you can build your app in a container, uh, and it can run in any scenario because you have packed up all your instruction into a say a jar, and you have given that jar to someone, so that and that jar is not tamperable. Okay, you cannot tamper from the outside. So that's a set of instructions that is given to the user or your colleague or anyone, so that he can use the same configuration, the configuration I am running here, the same configuration as well as the same requirements into it, and he can run the app exactly like what is exactly like the app running in my machine to his machine, the same one. So this is the concept behind the dock containerization of application. So and there is a only 4 minutes of time, so I'll just quickly tell you one more thing, very interesting one. So I don't have enough time. Okay, so there is a called CI/CD pipelines. I have mentioned that GitLab CI. So you just don't have to worry about what all these things are. So I have if you want to deploy your application to some server or something. Okay, so I have written a stage of having just build the application. There's no testing on anything. So this is the GitLab CI file dot GitLab -ci dot YAML. It's a YAML extension file. So once you put your file here and you just push your code to GitLab, so it will trigger a pipeline automatically. Okay, so this is the code I have in the GitLab. So we have this GitLab CI file. So once you have your GitLab CI file configured in your repository, so there once this repository gets your .GitLab CI, it will start running a pipeline as per the instruction written in the GitLab CI YAML. If you see, we have the same instructions. Now if we go in the pipeline, so this is the stage I have mentioned here. If you see, I have stage name build. So that's why the build stage is here. Now if I go into it, so whatever we did in the local system here, building the applications, all these steps will be done in the server. So if you see, it has what is called okay, yeah. So if you see, it has created a work directory hello.app, then copied to hello.app, then and did the requirements installation and all these things it has installed, and the dependency installation, everything it has done, and it has the job got succeeded. So once you go in the package and container registry, in the container registry, if you go, so you will have your image here. This is the image we have built in the local system, in the local Docker. This is the image. Okay, we have this is in our local system. Okay, this test one is in our local system, but this one is in the server of the GitLab. Okay, so this is the image. So this image also we can copy it, and there is a command. This is the copy command. So once you copy it, the link, this entire link will be copied, and you can use this image to any other location, any other container, any other machine to build on it, to deploy your applications. So this is very interesting topic, and if you want, you can work on it, and it's very useful, I say. So now, thanks for bearing me for 1.5 hours. And this is my contacts. If you want to contact me, you can contact here. So I think we are sharply on time.
It's almost 29 now.
It was a very wonderful session.
Yes.
Thanks.
It's
Thanks.
really
Monavita,
very
for
Any
having me.
questions?
Any question from the student side, participants? So I would like to also let you all know that this was live on our official YouTube channel. So you can later on again access the whole video if you have any doubt. You can go through the whole video there from the official YouTube channel of the ITP University. Students, if you have any questions regarding this part, please raise your question.
So if you have any doubt, you can drop a mail to Amrit also. He can reply in that way also.
Yeah, sure.
Any questions for now?
Any questions? You can unmute yourself. You can share the. You can unmute or you can just chat there in the chat box. Yes.
No
Yes.
questions, I guess.
Like yeah.
Okay, they can
So-
see it later on and they can
Later
drop
on,
a
I
mail
say
to
like-
Amrit.
Yes. Yes. So it is really nice having you, Amrit. Actually, on behalf of whole VITAP University, we the coordinators, Monamita Chakravarti ma'am and myself, really thank you for your valuable time and also all the effort you have given. Like I think
problem.
all
Akash
of
is
the
saying
students,
something.
yeah, Akash is okay.
Okay.
Thank you very much, Akash.
Thanks, Akash.
Thank you so much. So yes, I hope it is really very helpful for you all, to each of the participants here who really think to even work on this. Like this might have also motivated you all to work in this area. Those who had not worked in this area, or otherwise, obviously those who had some idea, it will be always helpful for you to gain more knowledge from such a it is
Yeah,
a great
it's a very
industry.
new
But
and trendy topic.
true.
It's a very new and trendy topic. You can just take some idea and start working.
Yeah, there are a lot of research scope in this Docker containerization. Even you can build a container inside a container. So there are a lot of opportunities going on in both the domains.
Charan is also saying it was really a very, very nice lecture. So thank you, Charan.
Thank you. Thanks, Charan.
It was really nice having you. So,
Thanks.
so you're on time. So thank you very much on behalf of the whole VITAP family. Ganesa is also thanking you. Thank you.
Thank you.
It was really nice for all the efforts and the way you present. It was really interesting. Thank you.
Thanks, Dr. Monali. Thanks, Dr. Monamita.
So
Thank
with
you,
this,
Amrit.
we can wrap up today's industry gas lecture. Thank you, everyone. Thank you for your valuable time. Thank you.
Thanks.
We can end the meeting here.
Yeah. Thanks, everyone. Bye-bye.
Have a nice.
Bye.